Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new topic regarding water hammer in pipes. So in this lecture, we'll discuss about what is the meaning of this water hammer and what are the causes of water hammer and what are the effects of water hammer and what are the prevention can be taken to avoid this water hammer. So first let's try to understand what is water hammer. So for understanding this water hammer, here I have taken a container and this container is like which contains of some fluid is there, and along with the container one long pipe is connected to this. Okay, a long pipe of AB, the name is mentioned, AB is connected to this, and this center line of this pipe, you can say, which is the head of, or which is the height of H from the surface level of the water. So this is the center pipe of the pipe and this is the inlet position of the pipe. So this is inlet and this is suppose the reservoir, or you can say a large tank is there, and this is the long pipe, and at the end of the pipe a valve is connected here. This is the valve position which is connected at the end of the pipe. Okay, so this is one end at the inlet part and this is other end, this is outlet part, you can say, and this is one like near to the outlet a valve is connected here. So when the liquid will be, or the fluid will be flows from this tank through this pipe, and it will come out from this at the outlet. So this valve is connected. So valve portion why you is connect to control the fluid velocity or to control the fluid flow. So when the valve will be opened fully, okay, when the valve will be opened fully, the fluid which is flowing through the pipe will come out with a high velocity or with a velocity of V. Which velocity is there here? With the same velocity, the fluid will come out from the pipe outside. Now, when the valve is fully opened, as I told you, when the valve is fully opened, then we can get the same velocity of fluid flow at the outside. Fluid fully opened means then the velocity of fluid will be high, velocity will be there, so it will come out. But when suddenly the valve will be closed or partially closed means again we'll get a reverse wave structure type. So a small wave will be formed, okay, with some pressure that is reversed to the reversed directions. Okay, when it is partially closed, when the valve is partially closed. So even that time also we need to consider when it is partially opened. That time also same velocity will be there, but the velocity value will be reduced. Okay, so initially the velocity is very high. Now this is in the medium range will be there, we can say. So though the velocity is reduced here, so what about the remaining velocity which was already initially we have? Now few velocity which is like here it is reduced, so that velocity will be create a waveform, and which is be moved in the reverse direction towards this, and that is actually some kind of, you can say, shocking type will be there, shock type will be there to the, and that will be form a waveform will be there. Now let this valve closed fully. Now the valve should be fully closed. In that condition, when the valve will be fully closed, then the momentum of the fluid, you can say here the velocity will be less, or we can say 0, you can say equal to 0. This is reduced, you can say. Okay, now when the valve is fully closed, in that time the momentum of the fluid which is flowing, so the momentum of the fluid will be completely destroyed. You can say the momentum of the fluid will be completely 0 or destroyed, you can say, because there is no flow through the pipe. So this momentum will be formed, a waveform will be there, like I told you, that will be started reverting backward directions. So this high pressure of wave formation, okay, that will be created by closing the valve suddenly. So this wave formation, due to this wave formation, that will be equal to the velocity of, velocity of the liquid, or you can say that will be this velocity will be equal to the velocity of a sound actually. Okay, so which is very, very high. And so this velocity of sound, as I told you, this velocity of sound equal to the velocity of water flow, and which is closed, and due to velocity of water flow which was stopped suddenly, and the momentum breaks. So due to this, a noise will be formed. Okay, a noise formation will be there, and that is called knocking. That is called knocking. Okay, so this wave, high pressure wave, will be transmitted along the pipe. You can say this is the pipe is there, so this wave formation will be transmitted along the pipe in the reverse direction. Okay, along the reverse direction, because there is a closure in the valve suddenly. So that will be equal to the velocity of the sound, and that is nothing but knocking. Okay, so this high pressure wave, or we can say the high pressure what is that form like wave formed, or you can say that knocking which is formed here, that also that also affects as a hammering action type. Okay, this high pressure is the effect of hammering action. That means it will feel like someone is hammered with a sub object to some place. So that high pressure will be creating also a hammering action. So this hammering action on what? On the pipe itself. This hammering action will be affected on the pipe of the in this. So this is this pipe. Okay, and that is known as water hammer. That is known as water hammer. So what it means? That means the knocking which is formed, okay, due to this reverse back of the fluid, or the momentum what was formed here. Okay, so which was stopped here, and due to that there is a high pressure wave formation happened, and due to that knocking created. Okay, due to this high pressure wave, we can say high pressure wave, the effect also like hammering effect will be there, and that is called water hammer. Okay, now the pressure which is raised here, as I told you, the pressure which is raised here, the water hammer depends on many factors, you can say. So the pressure which is created, let me tell you, some water hammer depends on few points are there. What is the velocity? What is the velocity of flow? Velocity of fluid flow. Velocity of fluid flow in the pipe. This is one point. Similarly, we can say what is the total length of the pipe. Okay, if the length of the pipe is very, very large, then this knocking effect will be slightly slowly it is going to be reduced at the end when it is coming to the initial stage. So that is also depend on the length of pipe. Okay, next is what is the time taken to close this valve. So next we can consider the time taken to close the valve. To close valve, if you are taking more time to close the valve, then that much effect will be not there. Slowly the effect will be like the momentum will be slowly reduced, so there is no effect. Suddenly if you closing the valve, then there will be more effect, more hammering effect will be there. And next I can say that material the pipe material what is used, so it depend upon the elastic properties of the material also. Elastic properties of this material. So these are the few points. What are the pressure rise here, water hammer, it depends upon this. These are the points. Along with that, some more points also there. Some effects, actually, some causes of water hammer also there. So that I'll write here. So these are some following, I'll write here the following points are the main causes of this water hammer. So one is the gradual closure of valve. This is the gradual, what I told you, that how we are closing the valve. So gradual closure of valve, this is one point. And second one, I can write sudden. If you are suddenly closing the valve, sudden closure of valve. And also we need to consider the pipe and pipe properties. In the pipe properties, two things will be there: whether the pipe is rigid. If it is the rigid condition, it is rigid property, then what will happen? If the pipe is elastic, then this is one more condition. So these things we'll discuss in our next lecture, but this is the conditions of that. Now few points I'll tell you, that what are the main reasons, for this water hammer, and how we can avoid this, and what are the causes will affect on this. So first one, let me write, this is the causes of water hammer, first one. So few points are there in this. As already I told you, one point you can see this sudden closure of this valve. So just write short form, valve closing. One point is valve closing. Second is, if suddenly the pump is shut down, or suddenly this water, this inlet part also, if you suddenly there is any kind of closing will be there. This is one condition I have told. Many conditions are there, or many options, possibilities are there where the water is flowing with the help of pump and some other accessories also. If suppose through the pump the water is flowing and the pump closed, shut down suddenly. So one more reason, pump shut down. Next point I can say, if there is a change in directions of the fluid flow. So one more reason is direction of fluid flow. This is one more point. And these are the main points are there actually. And one more is also there, like high water pressure is there. One more is high water pressure. These are some points are there which is causing the water hammer. Okay. And so one more thing, due to that, what are the effects will be there, or what are the points, like how we can identify there is a water hammer created. So that will be, that will be created huge sound. As I told you, noise will be more. So more noise will be formed. And second one, I can say, due to this water hammer, what is the effect will be there? Now the pipe can be damaged. The pipe will be damaged. Pipe damage. And what are the fittings will be there near to this pipe? In nut bolt fittings will be there. In that also we can see the fitting will be damaged. The fitting will also be damaged. Okay. So these are some effects of water hammer. And how we can prevent. So one more point. Just complete. What are the prevention can be taken to avoid this prevention of water hammer? So what are the things we need to follow to avoid this water hammer? Few points are there. One instrument is there to install the water hammer arrestor. Okay, water hammer arrestor, which will avoid this sudden water hammer. So by installing this one, we can avoid this water hammer. Okay, and we need to adjust the water pressure. The water pressure need to be adjusted. Okay, and we can install a slow valve closure. Slow valve closure. And these are some preventions we can follow to avoid the water hammer, because we know that due to this water hammer, these are the following effects which are formed. Like there is a huge noise will be formed, then the pipe can be damaged, and the fittings can be damaged, so that we need to do more work in that. So we can avoid these things, and these are some causes are there. So this is the main theory of water hammer the pipes. So I hope you understand this theory. If you are having doubt regarding this, you can give a comment on the comment box. Thank you all.